Okay, so using the fact that we just said angles are congruent and side lengths are proportion, let's look at some coordinate plane stuff and talk about things and kind of relate each together. So looking right here, are the two rectangles to the right similar? So since they're rectangles, all angles are 90 degrees, so boom, angles congruent. That's a huge fact. I mean, I'm going to draw this and I'm going to erase it, but every angle in rectangles are 90 degrees. That's something we're going to talk about more in Unit 10. So all the angles are congruent, check. Now we got to ensure side lengths are proportional. So can I do transformation that maps one triangle or one rectangle onto the next? Well, first, let's do this. All right, first I'm going to do XY arrow, and I'm noticing that like AD and HE, I'm going to try to match those up. Notice how that's 2 and that's 4. So I want to shrink by 1/2. So first I'm going to perform a dilation that makes everything, the triangle on the right, smaller by 1/2. So A is at 1, 2, 3, 4, 5, 6, 6, 2. So A prime will be at 1, 2, 3, 1. All right, so we got A prime there. And I'll even write that out. 3, 1. Then D is going to be at right there. D prime is going to be at 5, 1. B is going to be at 3. Now I got to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be at 3, 5. 1, 2, 3, 1, 2, 3, 4. Boom. B prime's right there at 3, 5. Getting super close to being done with this. And then C prime's right there at 5, 5. All right. Now, notice how the rectangles aren't oriented the same way. So I'm going to have to rotate. So this is a counterclockwise rotation, and I'm only moving one quadrant, so it's 90 degrees. All right, so number 2 is going to be, we'll just write it in words, counterclockwise rotation, 90 degrees around 0, 0, the origin. All right, and then when I do that, that takes AD, matches it up with HE, takes CD, matches it up with GH, BC matches to GF, so on and so forth. Bada bing, bada boom. All right, so these two rectangles are in fact similar. Yes, similar, because the ratios of lengths of their corresponding sides are equal. In other words, there's a scale factor. I'm just going to write yes, scale factor for sides, scale factor for side. This is very shorthand. I'll just say works, comma, angles congruent. All right, so remember, sides have to be proportional, angles have to be congruent. All right, next one. All right, now what's going on here? We got these quirky shapes, BCDO, HLKO. All right, how do I get one to map to the next one? Well, people might say, like, we're reflecting over here. That's not true. That's false. That's a popular one people want to say. Remember, we could reflect over y equals negative x. If you put a mirror there, though, or actually apply the rules, you can see that it doesn't work. All right, so that's actually not it. I just know that's a common mistake. So it's not a reflection over that, not a translation. It's actually a rotation. All right. And we're moving 2 quadrants, so it's 180 degrees. So we're going to rotate 180 degrees counterclockwise around 0, 0. All right, that's rule number 1. And in fact, I say I don't have the rules memorized. This one, I just know that the order, or the numbers, the order of the numbers A, B stays in the same order, but you just make them negative, such as like B is at 0, 2 B is at 0, 2. Now B prime is going to be at -2, or 0, -2. D is at 3, 3, 0. So D prime will be at -3, 0. C is at 2, 3. So it's going to be at -2, -3. Kind of hard to see, but that right there. That's C prime at -2, -3. And then O, we're just rotating around O to begin with, so O stays there. And I'll use black to make it nice and easy to see. All right, so we rotate it like that, and then we can see that everything just needs to get bigger by a scale factor of 2. All right, just to emphasize things like this length is 2, this length is 4, so we need to multiply by 2. This is 3, that length 6, so on and so forth. There's multiple ways to do it, so the next one is just a dilation. 1/2 x, 1/2 y. And you don't have to write down this next part, but for fun, you could describe this as a single transformation as -1/2 x, -1/2 y. That won't always be the case where you can just do one. I don't care if you write that down or not. All right, but that would show that all the angles are the same, because after we perform that dilation, angles are congruent because everything matches up nice. Sides are proportional, so we can say again, yes, similar. These two weird-looking quadrilaterals are in fact similar because they have a scale factor that works. In this case, it was 1/2 or 2. Oops, sorry. That should have said 2 all along. That should have been 2. All right. I don't know why I wrote 1/2. 2, 2, 2, 2. Hopefully you caught that. The scale factor was 2. We got bigger. Scale factor was 2, and all the angles are congruent. So anyways, we're going to officially say that now. So two polygons are similar if corresponding angles are congruent and corresponding side lengths are proportional. All right, I wanted you to write that down because students like to forget that. Proportional. All right, so what does that mean? Like, let's look at this. Angle A, angle E, B, F, C, G, D, H. All right. So we can even write that down. Angles are congruent. Angles are congruent. And then side lengths, ratios of sides. So this is going to look a little quirky right now, but we're just going to match up sides like A, B, and EF. So if those had actual numbers, let's just muscle through this right now. BC and FG, all these fractions would equal each other. Side lengths are proportional. Can be called the scale factor 2. But if I just take the random side lengths, match up so I matched up corresponding side lengths like AB divided by EF, BC divided by FG. All right, matching these up, all these numbers would be the same with actual side lengths. And what does that mean? I'm going to elaborate down here in this one. All right. So we just got a little bit more to talk to, but now we're going to do the same thing with the quadrilaterals above, but these triangles right here. So list congruent angles. All right. So here, right here, this is a similarity statement. This means similar. And this is a similarity statement. All right. So since angles are congruent, technically I don't even have to look at the triangle. I can just match up the first letters, the second letters, and the third letters. All right. So angle R is congruent to angle X. Angle Y or S is congruent to angle Y, and angle T is congruent to angle Z. All right, and then I can go ahead and mark that in my picture if I want. All right, check that the ratio of corresponding side lengths are equal. So this is kind of like what we were doing above, is like TR divided by ZX. Let's just write this out again. Then TS divided by ZY. I'm just matching up corresponding side lengths and I'm dividing RS and XY. All right, all these side lengths need to be proportional. All right, well, what does that mean? Well, let's actually start to look at the numbers. Like TY is 25, ZX is 15. So I'm just going to start plugging in things. I'm going to rewrite it, but now I'm going to plug in. So 25 divided by 15. TS is 30 over 18. And then RS and XY, 20 over 12. All right, and I'm going to shrink this just a little bit. Do these all equal each other? Do they all equal each other? And the answer is, well, what's 25 divided by 15? Let's plug that into a calculator. 25 divided by 15, 1.67. All right, so it's about 1.7. 30 divided by 18, 1.7. All these fractions equal each other. They're all equal, so check that the ratio of sides are equal. Check, all right? So since angles are congruent and you match up corresponding sides, divide them, they all equal the same number. These triangles are in fact similar, all right? Now, last thing before I cut you loose, if two polygons are similar, then the ratio of their side lengths of two corresponding lengths is the scale factor. What is the scale factor in example 1? So RST is the pre-image. So this is the pre-image, original. This is the final. All right. So since RST is the pre-image, we're just going to pick any side length. Let's do 18 and 30. Oops. Match up corresponding sides. 18 is the final. The original was 30. So the final was 18 divided by 30. Let's just get a decimal for this. I think it's going to come out nice to 0.6, all right, or 3/5 if we reduced. All right, so that's the scale factor. We went from here to here. It was a reduction, so it was 0.6.